Okay, everybody, let's get started. Tonight we'll talk about linear regression analysis. In practice, you can find sometimes some factors influence other factors. For instance, the customer's yearly incomes influence their monthly spendings. The customer's educational level influence their incomes. In practice, we use the linear regression model to find out the relationships among factors. I want to use an example to show everyone how to use this analysis model, linear regression analysis model. Joe is a mobile app developer. He has a fitness mobile app. Joe wants to bring his mobile business to the next level. He wants to know more about his customer population. Here we meet a new concept, population. I will explain this concept later in tonight's lecture. His question is, how would a user's yearly incomes influence the user's weekly length of usage of the fitness mobile app? His mobile app provides the health information to the customers. He wants to know how the user's yearly incomes influence how long the user would use the mobile app every week. Joe has more than 2 million user population, so it's impossible for him to survey the entire population. What he did is to draw a sample of 100 users. We meet another new concept, sample. I will explain this concept later. He drew a sample of 100 users and then asked each one of them how much they make every year, how long they use the mobile app every week. Joe's question is, what is the mathematical relationship between the user's yearly incomes and how long the user would use the mobile app? This is Joe's question. We want to use some technique to find out this relationship between the two factors, incomes and how long the user would use the mobile app. This is our question. Before I talk about the linear regression model, I want to introduce some concepts to everyone. Let's talk about the terminologies. First, population. A population is a group of something of our research interest. For instance, 2 million mobile app users. This is the population in this case. If you get a part from the population, then this part is called a sample. Yeah. For instance, Joe drew a sample of 100 users from the 2 million user population. Then these 100 users form a small sample of the population. Yeah. It's very important to recognize the difference between a population and a sample. I will explain the reason later tonight. The other two important concepts are dependent variable and independent variable. The factor that are influenced by other factors is called a dependent variable. The factor that influences other factors is called an independent variable. So remember the two definitions of dependent variable and independent variable. Dependent variable is a factor that is being influenced. Independent variable is a factor that influences other factors. Any questions so far? No? No question? Okay. Okay, let's use Excel to perform the linear analysis in this data set. Please go to eCollege. I recommend everyone to use Firefox. The reason is, if you use Firefox, when you download a file, you will see an option, save file onto your computer. Other web browsers don't have this function, so I recommend everyone to use Firefox. But if you are familiar to other web browsers, you can use other web browsers to download the data set. Let's go to week 11. It's already week 11. Time flies by. Question?
I got a question. Did you post the video from last week?
Yes.
Okay.
Yeah.
Anything?
Yeah, it's on eCollege.
Okay.
Yeah.
Thank you.
You're welcome.
When you post videos, I tried looking for videos for every week.
Yeah, not available. Not every video is available. Yeah, some is not available. I'm still processing them.
Okay.
Yeah. Come in. Please go to week 11 and then download the source data file. Click source data fitnessapp.csv. CSV is a format of CSV is a format of storing data. It means the data are separated by commas. Yeah, C represents comma, S represents separated, V represents value, comma separated value. Yeah, it's just a format. It doesn't influence the value inside of the source data. Let's click fitnessapp.csv. If you are using Firefox, click Save File, and then download this file onto your computer where you can find it. It doesn't matter where you save it, just as long as you can find the source data, you can save it into the directory. Let's open the source data. In this data set, we ask each customer how long the customer used the mobile app every week. As you can see, we store data in the hours column. How much he or she makes every year, we record this data, this answer in the incomes column. How many times he or she visits gyms every week, we record this value in the gym visits column. And also where this customer is from, which state he or she comes from. We'll use this data tonight as well. Yeah. We call the state data, the geographical location data, categorical data. I will tell everyone how to perform data analysis on categorical data tonight as well. First, let's answer Joe's question. He wants to know how the user's yearly incomes, the incomes value, influence the value in hours. How about we draw a chart to show the relationship between the two factors? This is how we draw the chart. First, you want to select A1 to A101. A1 to A101. Select this range. Then you want to press and hold the Control key on your keyboard. Control key. And then select D1 to D101. Select these two ranges. Next, you want to click Insert tab on the top. Click Insert. And then you want to choose some graph called Scatter chart. Click Scatter, the little triangle on top of Scatter, and then select the first option of Scatter. Now you can see a chart show up in your Excel file, right? This chart shows the relationship between hours and incomes. We can see there is a trend in this chart, right? What is the trend? Oh, by the way, the value on the x-axis represents the customer's yearly incomes. The value on the y-axis represents how long he or she will use the mobile app every week. So from this chart, what kind of relationship can you make? Can you get? Very good. Yeah, there is a trend between the customer's incomes and how long she will use the mobile app, right? As Musu said, the more incomes the customer has, the more hours she will spend on this fitness mobile app. Yeah. From this chart, we can get an intuitive conclusion. But it will be better if we can get the exact mathematical relationship between hours and the incomes, right? We want to show a mathematical relationship. We want to show how the incomes influence the hours in a mathematical way. That will be better, right? This is how we will perform the linear model in Excel. First, let's select the boundary of the chart. Let's remove this chart. Oh, by the way, this is something called the data visualization. Yeah. In practice, you want to get very familiar to how to draw charts, graphs between factors so that you can show the relationship in a very straightforward way. When you try to get sponsors from senior managers, you want to use this kind of charts or graphs to impress them. Yeah. Usually, the senior managers don't have a lot of time reading all of the reports, data reports, right? They want to see the results or the relationship in an easier way. Data visualization is a very important tool. Let's click the blue boundary around the chart. Let's select this chart and then delete this chart. We don't want it. We want to build a mathematical model to show the exact relationship between incomes and hours. How incomes influence hours. This is what we want to do next. First, click the Data tab on the top. Data tab. We'll use a new option called the Data Analysis Add-in. Data Analysis Add-in. Does everyone have this option on your Excel software? Yes? Very good. If you don't have this option, click File tab. Click File tab. And then click Options. And then in the Add-in tab, click Add-in. At the bottom, click Go next to Excel add-ins. And then check the box before Analysis 2-pack. Analysis 2-pack. And then click OK. When you go back to the Data tab, you will find the Data Analysis option. Yeah. This is how you get this add-in. Click Data Analysis. In this window, we want to choose Regression option. This is how we perform linear regression in Excel. Choose Regression. And then click OK. Next, we need to select the ranges for Y factor and X factors. We usually use Y, the letter Y, to represent dependent variable. The letter X to represent independent variables. Yeah. Obviously, the Y range should be the hours column, right? Click the button next to Input Y range, and then select hours from D1 to D101. So you should have a $D, $1, $D, $101 in the Y range. Next, you want to choose the X range. In this case, we choose incomes as the independent variable, right? So let's choose the incomes column, A1 to A101. Select this range. Next, we want to check the box before labels to indicate the title row is on the top. Yeah. Next, we want to check confidence level, 95%. I will explain the confidence level very soon. Next, we want to check the box before residual plots. Residual plots. I will explain the function of residual plots as well. Finally, you want to tell Excel, do you want to output the results into a new Excel file or a new worksheet? It doesn't matter. It's up to the data analyst. Let's choose a new workbook. And then click OK. This is the data analysis results. More important, we want to learn how to explain the meaning of the results, right? Yeah. I have already captured the result into the PowerPoint. So let's use the PowerPoint. Okay. When you get the data analysis results from a linear regression model, the first part you want to look at is the coefficient parts. Coefficient. This data shows how your independent variable influences the dependent variable. From this report, you can write the equation like this. Hours equals to 1.463, which is the value for the intercept, plus 0.066 times incomes. The reason I use 0.066 times incomes is the report tells me to do that. Yeah. The coefficient for incomes is 0.066. I round the number to 0.066. According to the coefficient, you can write an equation like this. Basically, we build the mathematical relationship between incomes and hours based on the coefficient report. Some classmates may have a question. I built this equation. What is the managerial implication to me? How can I use it? How can I use this equation? Dolly, what do you think? We get this result, right? We answered Joe's question. But how can Joe use this equation?
Increase it one. If a person is getting income as one, so he will get to know how many hours.
Very good. According to this mathematical equation, in the future, if we don't know how long the user will use the mobile app, as long as we ask her how much she can make every year, we plug in the number to replace incomes in this equation, then we will predict how long the user would use the mobile app, right? Suppose the user can make $100,000 a year. Yeah. We plug in 100 into this equation, then we can predict she will use the mobile app for about 8.06 hours. This is the managerial implication of this equation. So remember, when you get the data analysis report, the first step is to look at the coefficients to build a relationship. Notice that after the coefficient of intercept, we don't times anything. We just type in the coefficient of the intercept directly. Yeah. This is how you use the coefficient for the intercept. I just introduced two concepts to everyone, right? The population and the sample. What is a population? It's the entire group, right? Yeah. If we are able to, we have enough money, enough labor, we will survey the entire population to understand a business question, right? But because it's very costly, it's impossible for us to survey the entire population. What we did is to draw a sample, a smaller group from the population. Yeah. Based on the sample, the 100 sample, we build the relationship between hours and the incomes. But there is a question we didn't answer. Are we interested in the population or the sample? Population, right? Yeah. We are interested in population because it's too costly for us to study the population. That's why we draw a sample. Yeah. Now we build a relationship based on a sample. The next question is, how can you convince Joe that the relationship from a sample is also applied to the population? How can you convince him? This is a very good question, right? Yeah. As a business manager, let's say you work for the presidential candidates. Yeah, you work for Donald Trump and Hillary Clinton. You work for them. Yeah. You want to predict how likely Hillary Clinton will win in Texas. Can you survey the entire population in Texas? Impossible. So what they did is to draw some sample from Dallas, some sample from Austin, some sample from Houston, right? Major city. About 100 residents from each city. And then they probably will build a mathematical relationship. Next, you need to predict the population, the entire population in Texas. How can you convince the presidential candidate that your mathematical model is robust, is very strong? How can you convince them? You have to look at something called a p-value. P-value. Do you remember we just specify the confidence level as 95%? Yeah, 95%. Those are confidence level. That means we are very confident about the model in this interval, right? If you use 1 to minus 95%, you will have a 5%, right? 5%. That 5% is called the level of significance. Level of significance. After you establish your level of significance, you want to rate the data report. You want to compare the p-value from the data report to the level of significance. Yeah. The rule of data analysis is if your p-value from the data report is less than the level of significance, we call that independent variable a significant influential factor of your dependent variable. Keep this in mind.
Could you repeat that again?
Yes. After you establish your level of significance, 5% in our case, right? You want to compare the p-value from the data report to the level of significance, this 5%. If the p-value for independent variable is less than the level of significance, we call that independent variable a significant influential factor of the dependent variable. Yeah. If the p-value is less than the level of significance, we call the independent variable a significant influential dependent variable of the influential factor of the dependent variable. Let's see an example. So we just talked about the coefficients, right? The next factor we want to look at is the p-value. Where is the p-value? The p-value is about 3 columns away from coefficients in the data report. As you can see here, p-value. You want to compare the p-value for each factor to the level of significance. 5%, right? In our case. Yeah. In Excel, if you want to show a very small number, you use letter E to represent 10. 10 with the power of a negative number shows a very small number. For instance, in our case, incomes, right? We look at the p-value for incomes. It is 5.21 e negative 24. That means 10 with the power of negative 24. That means 1 over 10 with the power of 24. That will be a very small number, right? You want to compare this number, 5.21 e negative 24, to the level of significance, 5%. Is this p-value less than the level of significance? Less than or greater than? Less than, right? 5.21 times a very small number, 1 over 10 with the power of 24. That will be a very small number. Yeah. Obviously, this value is less than 5%. Then we should make a conclusion. Incomes is a significant influential factor of ours. What does significant influential factor mean?
A small change in the
That means the relationship you predict from a sample can be applied to the population. This is the conclusion you can make.
Now what?
That means the mathematical relationship you predict based on the sample can be applied to the entire population. Yeah. That means if you draw anyone from this 2 million population, ask how much the user make, plug in the number into the equation, you can predict how long the user will use the mobile app. The 2 million user population will probably follow the same mathematical relationship you built from the 100 sample. That was what the significant influential factor means. Some classmates may have a question about the p-value for intercept. Do we need to look at the intercept? Sometimes when you get the result, the p-value for intercept is usually, sometimes it's not significant, which means the p-value for intercept is greater than level of significance. Do we need to care about that? It doesn't matter. It doesn't matter. Yeah. Let's say you have p-value for the independent variable is a significant influential factor, but the p-value for intercept is greater than level of significance. Then what kind of conclusion can we make?
You said
If the p-value for the intercept, right, for 1.464 is not significant, what kind of, but the p-value for incomes is significant, what kind of conclusion can you make?
still the same.
Then you can ignore 1.464. You can say in the population, ours equals to 0.066 times incomes. Yeah, because we ignore that. It's not significant. Yeah. But what does the intercept mean? That means you don't consider any other factor. You just randomly choose a customer from the population. Averagely, this customer will use the mobile app for about 1.464 hours every week. Yeah. We don't consider any other factor. We don't consider incomes. We don't consider team visit. Just randomly choose a customer. Averagely, the customer will use the mobile app for 1.464 hours. This is what the intercepts mean. Yeah. So that's why if the p-value for intercept is not less than 5%, it doesn't influence your conclusion because it shows a natural average value. Yeah. Any question?
If it is significant, would it add anything else?
Yes. If the intercept is significant, then when you report the final result, you should add the intercept value. Yeah. If it's not significant, when you predict the population, you don't have to add it in. Yeah. But what if the p-value for incomes is not significant? What should we do?
And it's not a proper representation.
Yes. Yeah, we cannot predict the population has the same mathematical relationship, as you can see on this slide. What should we do? We have to look for other samples, from other samples, until to get the value until the p-value for the incomes is significant. That will be a representative sample. If the p-value for incomes is not significant from the current sample, that means the current sample is not representative of your population. Yeah. Because you cannot infer the mathematical relationship from this sample to the population. If you want to look at the population behavior, you must find a representative sample. Sometimes people will say, I want to choose 1% as the level of significance. Can we do that? Yes, we can. If you are given 1% as the level of significance, you compare the p-value from your data report to this 1% level of significance. If the p-value is less than 1%, then you can say that independent variable is an significant influential factor. Otherwise, it's not a significant influential factor, which means you cannot infer the population has the same relationship. Yeah. Obviously, 1% is a criteria that is harder to pass, right? Right? 1% is harder, it's more stricter. That's why in medical research, if you want to develop some new medicine, some new drugs, you usually use a lower level of significance to make the criteria more stricter. But in business research, 5% is broadly used, broadly acceptable. 5%.
So what do you advise them to use? 10%,
5% is acceptable, 1% is better. Yeah. This is the second factor we want to look at, p-value. Next, we want to look at a factor called the R-squared value. The formal name, R-squared value, is a nickname. The formal name for R-squared value is called the coefficient of determination. Yeah. Because most of the software will report this value as R squared, so people will give it a nickname, R squared value. But don't forget the formal name. Yeah. The formal name is the coefficient of determination. No matter how this value is called, we have to understand the meaning of this value. What does this value represent? It represents the percentage of the dependent variable's change that can be predicted by the independent variable. This value has nothing to do with the model you just built. The R-squared value represents the percentage of dependent variable's change that can be predicted by the independent variable. In our case, we have a R-squared value and the adjusted R-squared value. You can choose either one. Yeah. They don't have a big difference. You can choose either one to interpret the R-squared value. But no matter which value you choose, it's about 64%, right? 0.64. 64%. What does this 64% mean?
Change in the independent variable will influence the
This means if your dependent variable changes by 1 unit, $1, 1 person, 1 hour, doesn't matter. 1 unit, 64% of this 1 unit change can be predicted or explained by the independent variable. Remember this. This is how you use the R-squared value. Some classmates may have another question. The more percentage I have for the R-squared value, the more powerful of my model, right? Yeah. I use incomes as one independent variable. I can explain 65% of the dependent variable change. What about the other 35%? How can I explain the other 35%? We can add more independent variables into the model, right? Yeah. Let's see another example. Let's say we want to add incomes and gym visits as 2 independent variables together into the model. How the R-squared value will change. Let's go back to the data set. When you use 2 or more independent variables, the process of performing the linear regression analysis is very similar to the one we just did. Yeah. Let's go to the data set and then click data tab. And then choose data analysis. We want to choose regression and then click OK. The range for the Y range is the same, right? We still want to predict how long the user will use the mobile app. But the range for the Y range is changed in this case. We want to click the button next to input X range and then choose A1 to B101. We want to select both incomes and gym visits. So you should have A1, B101, and then click confirm. Same thing, we check the label box, we check the confidence level, we check the residual plot, and then click new workbook, and then click OK. These 2 charts are called residual plots. I will explain the function of these 2 charts later tonight. But let's look at the data analysis report. Which factor should we look at first? Coefficients, right? Yeah. I already captured the results, so let's go back to the PowerPoint. Coefficients. Now we get the values. According to the report, can you build a mathematical relationship to explain how incomes and gym visits influence hours? What should be the equation?
0.38 0.06 incomes plus 0.5 gym visits.
And then plus 0.3282, right?
Yeah.
The intercept. Yeah. First, we want to look at the coefficient. As you can see here. According to this value, we can build the mathematical equation like the one you can see at the bottom of this PowerPoint. Hours equals to 0.3282, which is the coefficient for the intercept, plus 0.061 times incomes, plus 0.5001 times gym visits. How can we use this model? Suppose we don't know how long a new customer will use the mobile app. We ask the values for incomes and gym visits. Based on this equation, we can predict how long the new customer will use the mobile app, right? Yeah. Oh, by the way, you can see the more incomes the customer has, the more hours she will use the mobile app, right? The more gym visits predict more hours, more usage hour, right? That means customers with higher incomes will be more health conscious, right? We can make this conclusion. Customers who go to visit gyms more frequently is more health conscious. That's why they use the fitness mobile app more. Yeah. If you work for the marketing department for this studio, then you want to put your advertisement in the gym, in local gym, right? To raise awareness of your mobile app. You want to target on the customers with higher yearly incomes. Yeah. Because based on this model, they are more likely to use your mobile app longer. Yeah. This is the first factor. Second factor, p-value, right? Yeah. We built this model based on 100 users only. Now we want to predict if this equation can be applied to the 2 million user population. We want to compare p-value for each independent variable to the level of significance. Let's say the level of significance is 5%, 0.05. So we compare each p-value to 0.05. Looks like the p-values for incomes and gym visits are less than 5%, right? Less than. They are a very small number. But the intercept is not less than 5%. It's greater than 5%. So if you want to predict how long the customer from the population will use the mobile app, you should use hours equals to 0.061 times incomes plus 0.5001 times gym visits. In the population, you don't need to consider the intercept because the p-value for intercept is not significant, right? Yeah. You cannot bring in 0.3282 into the population. Also, it's a very small number, so it doesn't influence your results very much. Yeah. That's acceptable. If you want to get a perfect solution, then you have to keep drawing different samples until all p-values is less than 5%. That will be a better solution. But from this report, we can say we can predict the equation in the population. We can apply the equation into the population. Third factor, R squared value. Yes, very good. R squared value. What is the R squared value now? 79%. Yeah. Obviously, when we add more independent variable into the analysis, we consider the same factor, hours, from different perspectives, right? Our model is able to predict more percentage of the dependent variable change. Yeah. Before, when we have one independent variable, the R squared value is only 64%. But when we add gym visit as the second independent variable, the R squared value increased to 79%. Yeah. That means if hours changes by 1 unit, 1 hour, right? 79% of this 1 unit change can be explained or predicted by incomes and gym visits at the same time. Yeah. You have more predictive powers put together.
Is that where you can drill it down to know which contributes, which can be explained by which?
Yes, yeah. First, you have to perform the one independent variable analysis, right? 64%. Yeah, that means incomes can explain 64%, right? And then you add the second factor into your model. You find out that the R squared value increases.
Yeah, so
increases to 79.
So you're saying if income explains 64%?
Yeah.
and income and gym visit explains 79%.
Yeah.
So are you saying gym visit only explain?
Only explains about 15%.
About 15%?
Yeah,
Okay.
it's 15%. Yeah. This is how you see the percentage of predictive power from each independent variable. Yeah. Keep adding new independent variables into your mathematical relationship. The rule of thumb is the more independent variable you add into the equation, the larger the R-squared value will be. Yeah. It's very reasonable because you consider the same factor from different perspectives. Yeah. Very reasonable. Not difficult to understand. If you only have one independent variable in your linear regression analysis, then this analysis is called a simple linear regression analysis. Remember this. Simple linear regression analysis. If you have two or more independent variables, we call this analysis multiple linear regression analysis. Yeah. I want to stop here. Let's take a break, and then when we come back, I will talk about the residual plots and then the dummy variables.